Hi, I'm Margaret Hedeman, and I will be presenting about Hemoltz clouds. So, some characteristics of Hemoltz clouds is that they can occur at any three of the cloud levels, which means that it doesn't matter what altitude they are at. And they're known for being very fleeting, so they only last a couple of seconds. I'll explain that later. And they occur during a temperature inversion, and they are caused by wind shear, and I will explain both of those things in the later slides. So they were discovered by Lord Kelvin and Hermann von Helmholtz in the mid-19th century. So this first picture is the beginning, then middle, then end. So it forms basically when there's a velocity difference between two fluids, in this case air. It can also happen in water. So this picture shows two fluids going opposite directions, but it can also happen just having a velocity difference. So the bottom fluid could be stable and the top one could be moving, or they could be moving in the same direction just at different velocities. So when this happens and there's a small deviation between the two fluids, it just gets bigger and bigger. The white dots represent the air molecules. And then this last picture shows that in the smaller space right here, the air travels faster because there's a decrease in pressure. And therefore, this little hump right here keeps growing and growing. And when this happens, eventually the hump will get so far up that the fluid on top will just push it over, creating that wave type look. So when does this happen, and how does it relate to temperature inversions? So this is normal conditions during an unstable atmosphere where the warm air is on the ground and the cool air is on the top. But during a temperature inversion, there's a layer of cold air, then warm air, then cold air again. So between the cold air and the warm air, a bunch of clouds form because they cannot keep going up into the atmosphere. And the warm air layer travels faster than the cold air because the cold air is denser, and this creates the difference in velocities between the two air layers. It won't let me watch this video, but it basically just shows this same instability in fluid. So what happens is the air on top is traveling faster than the water on top is traveling faster than the water on the bottom. And it's so fleeting because once this occurs, the turbulence just keeps going and it kind of dissipates all on its own. Thank you. I'm Margaret Hedeman, and you just learned about Hemoltz clouds.